Hi students, welcome to Alphos e-learning program Mathematics. In previous sessions we have discussed about parabola where the axis is exactly here parallel to x-axis or parallel to y-axis or along x-axis or along y-axis. Now we want to discuss about not only those parabolas but sometimes parabolas they are having axis like this, that means it is coming as oblique line, neither perpendicular to x-axis nor to y-axis. Then how the equations and what about the standard form of this oblique parabola etc. let us discuss now. Now students, let us observe here the known form, that is our y square equal to 4ax. Okay, this is the known form, y square is 4ax. What is the nature of this y square is 4ax? Suppose if I consider a parabola of this form, okay, this is the parabola and now you know this is our axis of parabola and next one this is our tangent at vertex, okay. So this is tangent at vertex and this one is axis of parabola. Let us consider here a point P of x1 comma y1, any point on the curve. Now if I take here this value perpendicular distance onto axis of parabola, here we say x-axis as well as axis also. Now this is nothing but, suppose if I take m here, this value is exactly y1, okay. That means perpendicular distance from a point P onto axis of parabola is y1, okay. And next one is perpendicular distance from here point P onto y-axis. And now here that y-axis here, it has a significance, that is tangent at the vertex. Now this value is here how much? x1. Suppose this value we are writing n. Now in this way if I take, then what about y square equal to 4ax? Y square is 4ax means you are taking perpendicular distance from a point P onto axis whole square. Understand? Axis whole square and equal to this 4a is nothing but if you take latus rectum and into x means it is perpendicular distance from P onto tangent at vertex. Then what will happen? Simply we can generalize. Similarly you take a point here x2 y2, x3 y3, x4 y4, like this here whichever point you take on the curve, they are satisfying a relation and that relation is nothing but here perpendicular distance from a point onto axis whole square is same as latus rectum into perpendicular distance onto tangent at vertex. So let us write here that kind of equation. What about the value? So it is perpendicular distance, right, from which point here? From P of x1 comma y1 and this point is nothing but any point on the curve. From P of x1 y1 on the curve, okay, on the curve, onto which one here? Onto it is axis whole square. This entire value whole square is equal to latus rectum. Understand? Latus rectum length, that is 4a, and into it is perpendicular distance from which point here? Same point, it is P of x1 comma y1, same point P of x1 y1 onto, now this is nothing but here tangent at vertex, okay, tangent at vertex. So this is the significance of the point x1 comma y1 on the curve y square equal to 4ax. So basing on this significance, this is our latus rectum and y square is this one axis and here it is tangent at vertex. That means the second degree you are getting here exactly for axis and the first degree is for tangent at vertex. Now not only you may think here this is only for y square is 4ax, okay, it may not be or it may be even for minus 4ax, but what about here x square equal to 4ay, okay, x square equal to 4ay. So now here you observe this is the parabola x square equal to 4ay, right? And now if I take this parabola x square equal to 4ay, so like this the curve, and now what about here tangent at vertex, this one is our tangent at vertex and next this is our axis of parabola, right? And now here what is P of x1 comma y1, so this is the point P of x1 y1. Now what is the equation? Actually the standard form is x square equal to here 4ay, right? Now from the point P of x1 y1 I am taking perpendicular onto here exactly axis. Then what about this distance here? It is nothing but x1, because here you know here this is origin and thereby this part is our x1 value. And now here what about here? Perpendicular distance from P onto this is tangent at vertex. This is here y1. So students, you can observe here perpendicular distance from P onto axis whole square, that is x square, and equal to latus rectum into perpendicular distance from P onto tangent at vertex. That means here that kind of concept it is applicable for any kind of parabola, either it is y square is 4ax or it is x square equal to 4ay, right? That's why you can generalize this concept not only for y square is 4ax, even for any kind of parabola. Hence students, we can observe here for this one, suppose the oblique lines are, one line I am taking here, this is our tangent at vertex, okay. So this is the tangent at vertex. Suppose the equation is Lx plus my plus n is 0. Earlier we have taken x is constant or y is constant, but now we are taking the line as Lx plus my plus n is 0. Then immediately what about axis? Because all of us know tangent at vertex is always perpendicular to which one here? Axis. Therefore, what is axis equation? Here slope is minus L by M. Therefore, here it has to be M by L. Product of slopes must be minus 1. Then that equation is mx minus Ly plus some constant is 0. So now here these two lines are exactly perpendicular. We have taken tangent at vertex as this one and axis of parabola as like this. Okay students, now after this here let P of x1 comma y1 be any point on the curve. If P of x1 y1 is any point on the curve, then what is our formula? Perpendicular distance from P of x1 y1 on the curve, and this is onto axis. Okay, point is on the curve and the distance you are taking onto axis whole square. Then what is that condition here? Axis is this value, right? This is our axis value. So if I write, it is mx1 minus ly1 plus k divided by the value under root of m square plus l square. This is perpendicular distance from P onto which one here? Axis, and axis equation we have taken like this. Okay, so this is our y1 square, and to this you have to take how much here? Whole square, and this is equal to latus rectum into, what is latus rectum into? It is perpendicular distance from P of x1 y1 onto tangent at vertex. So what is tangent at vertex? We have taken here Lx plus my plus n is 0. You can name them anyways. Here you can start Lx plus my plus n is 0, and then you can take this as mx minus ly plus k is 0. Anyways you take, but the thing is here the two lines are mutually perpendicular. That's it. Therefore here latus rectum into perpendicular distance we are talking. Therefore mod symbol. So what is the mod symbol? We have to write here mod of Lx1 plus my1 plus n and divided by what is this value here? Root of L square plus m square, right? So in this way we can generalize the equation of this parabola, oblique parabola. So main concept students here, if you take P of x1 y1, if it is any point on the curve, then perpendicular distance from P on the curve, which is on the curve onto axis. So this is the axis we have taken, and this is equal to latus rectum into perpendicular distance from the same point on the curve to tangent at vertex. So this is our tangent at vertex into latus rectum. So this one is very, very important. Just if you remember this one, you can write whatever the lines given in the problem, it can be. Now you can observe in the diagram dotted lines I have taken and this side. Okay, dotted lines I have taken this side. That is here you are taking mod symbol. Mod symbol you are taking means this also you can observe here. This is axis, means to this parabola if I draw like this, then here also this is our axis. And next one, to this parabola you can take here tangent at vertex. That means whenever you are writing this kind of equation, then the parabola can be in this way or the parabola can be like this also. That means with this data you are going to get here two types of parabolas. And what is the right value, how we can decide is given numerical values. Whatever in the problem, sometimes they give focus must be in first quadrant, or they may give focus must be in third quadrant or second quadrant. Like that they define some data. Accordingly we can decide exactly here plus symbol we have to consider or minus symbol we have to consider. So students, finally this is our equation of which one here? Oblique parabola. Now this side, that means the second degree always represents which value here? Second degree is representing here axis, and the first degree it is representing here tangent at vertex. So you can remember axis square latus rectum into tangent at vertex. Now basing on this here, they ask different kinds of questions. What kind of questions they may ask? So first here, this is our perpendicular distance onto axis, you have to remember, and this one is, this value is nothing but latus rectum into the same perpendicular distance onto tangent at vertex. Here we are not bringing the directrix, okay? The concept is here moving around axis and tangent at vertex. So now we are not bringing here focus and directrix in the scene. In these model problems, they ask about what is the vertex. If at all they ask about vertex, clearly all of you know very well, that is vertex is nothing but point of intersection of axis and tangent at vertex. Therefore, you can say if you solve these two equations, if you solve just these two equations, that is nothing but a vertex, okay? So easily you can find here vertex by solving. Suppose if I write this as y square is equal to latus rectum, that is some here into here, this value is x, okay? If I write in this way, then what is here? Vertex value. Vertex can be obtained here by solving which values here? X is 0, y is 0. Point of intersection of, we can say x is 0, comma, y is 0. So this is the vertex. That means here mx1 minus ly1 plus k is 0 and lx plus my plus n is 0. This I have taken just for one point x1 y1, and you can generalize it just by removing not only for x1 y1, it can be true here for any point on the locus, right? Now in this way you can take this is x is 0, y is 0, which is nothing but point of intersection of axis and tangent at vertex. And next one, suppose we require focus, isn't it? For this kind of data, I want focus. Then again, what about here? Focus to y square is 4ax kind, it is equal to x equal to a. Or it can be here x equal to minus a. Understand? That means we write the value as here how much? X comma y is equal to, what is the value here? A comma 0. Understand? Or it can be how much it is? It can be here x comma y is equal to minus a comma 0. Depending on here mod symbol plus or minus. Then to find low focus here, you just take x equal to a, that is point of intersection of, we write x equal to a comma y is 0. That implies what is that point of intersection? Directly you take here mod value, that implies x place you are having tangent at vertex, that is mod of. In this place completely you are having as it is, you have to take students along with the denominator. That is very important. Understand, this entire thing is y and this entire thing is here x value along with the denominator. That is important. So this is mod of lx plus, understand, my plus n divided by root of l square plus m square equal to a comma y. Y means this value mx minus ly plus k. Anyhow this side 0 is there, so I am not writing here denominator. So point of intersection of these two values. Now minus a not necessary to write because already you are putting here mod symbol. Altogether you will get here two types of coordinates which can be here. This can be this side or this side, or if the parabola you are getting in this way, therefore one is this focus and this is another focus. and numerical values, just basing on our data we can define exactly which focus you are going to get. Okay, so what is the formula for here focus? Focus is nothing but x comma y. Actual formula a 0 or minus a comma 0, because here lattice rectum minus 4ax or plus 4ax, and after that you got here point of intersection of x equal to a, or you can write minus a, any value, and y equal to 0. And what is x equal to a here? Actually tangent at vertex, that entire thing, perpendicular distance. Okay, that means the denominator part is here very important. So this entire value equal to a and y is 0. Y means here axis equation. So if you solve these two equations, then easily you can get here coordinates of focus. And next part is what usually we require. Already you are having tangent at vertex in the data, axis in the data, and they will ask about here what about the other part, directrix equation. So what about directrix equation? The formula is nothing but, to this standard form it is x is equal to minus a, right? And that means here x is minus a means it is nothing but, how you have to consider it is, this side you are having x, that is mod of Lx plus my plus n, and divided by root of L square plus m square is equal to how much? Minus a. So you will get here that side directrix or this side, and again by data we can take which is finally. Okay, and this one is here equation of directrix can be obtained from this. And similarly lattice rectum equation. So equation of lattice rectum, if at all they ask here, what about that value? It is exactly x is equal to a. Okay, so this is exactly our equation of lattice rectum. Therefore students, here in this oblique model even we can find all kinds of values. Okay, so remember this is very important, the denominator part here it is very important. And lattice rectum also you can decide only once it is completely in the standard form. If I leave the problem just like this, that means what is lattice rectum of the parabola? X minus y plus 3 whole square is equal to x plus y. Suppose a problem is given like this, then immediately you are not supposed to decide the lattice rectum is 1. Okay, what is important thing here? The denominator part is important, because we are referring with perpendicular distances, implies x minus y plus 3 divided by root 2, 1 square plus 1 square whole square. Now I have taken 2 extra here, therefore multiply by 2. Then this side you are having x plus y divided by root 2. Again what is the extra term? We need to multiply this value. Okay, finally what is the answer? X minus y plus 3 by root 2 whole square and equal to, this is 2, if you divide it is 1 divided by how much the value? Root 2, and it is x plus y divided by root 2. Then students, now you can decide exactly this is our length of lattice rectum. Okay, so what is length of lattice rectum now? 1 divided by root 2. And after that what should be your observation? The equation of axis, it is nothing but x minus y plus 3 equal to 0. And equation of tangent at vertex, that is the first degree one, that is x plus y is 0. And if you solve these two equations, you are going to get which value here? The vertex value. Okay, and once you got vertex, again you can find easily the other also, that is directrix, everything. Okay students, now let us see here the problem. Find vertex length of lattice rectum, like that different values they can ask for this kind of equation. Now earlier students, if you observe that different kinds of equations from the past parabolas, those are y square is 4ax, x square is 4ay, right? And the next one is here y equal to lx square plus mx plus n. Like this here you observe different kinds of equations, or x is l y square plus my plus n. So what are our observations from these 4 kinds of equations? the variable x and y are here variables. If one variable is in second degree, the other variable is falling as first degree. Okay, whatever it is, x or y, but one variable is in second degree, the other variable is in first degree. Now everywhere you are observing like that. So if equations are in that way, then you can observe clearly here axis is parallel to x-axis or y-axis, or axis is along x-axis or y-axis, as long as the one value is in second degree and the other variable is in first degree. Okay, so just by observing these equations you can say here axis is here along x-axis or y-axis are parallel to them. But whenever any equation is coming as second degree in x and y, both x and y, it is coming as second degree. Okay, in both x and y second degree, and the equation is a parabola, means here axis cannot be either parallel to x axis or parallel to y axis. So what will happen here? It is surely oblique parabola. So just by seeing it you can say here the parabola is an oblique parabola or horizontal or vertical parabola. So here x square present, y square also present. In xy you got here second degree equation, hence the parabola can be of this form or of this form. Like this it can be any ways. Moreover, it is just an oblique parabola. Now to this kind of parabola they are asking about what about vertex, etc., all the values. So just now we have observed about the nature of this parabola, how the equation exists. Now how we have observed here, one side it is perfect square and the other side is not at all a square. Okay, so one side you got perfect square, the other side the equation is just of first degree. Then the homogeneous part you observe. Okay, the homogeneous part, of course here delta value is not equal to 0 and h square value you got equal to AB. Okay, so the homogeneous part if you observe every time it will be a perfect square as long as here parabola is concerned. Now this one if I write the value, it is 3x minus 4y, how much it is? Whole square. Got all of you? 3x minus 4y whole square. If you expand this one directly you can get. Then the leftover terms simply we send the other side. This is 20x plus 15y plus 60. By taking, let us take here 5 also common. Then this will be 4x plus 3y and minus 12. That means plus 12. Okay students, so what is the first observation? The homogeneous part. And how is the homogeneous part here? 3x minus 4y whole square. And next the other part if you take, this is minus minus we are having, so I am sending that side, and everywhere you can take here 5 common, so it is 20, 15, 60, right? And now here we can't say just here the equation part completed. What is more, we have to check here perpendicular distance. That means the denominator should have here how much? Under root of 3 square plus minus 4 square. That means you know clearly it is nothing but 5. Okay, therefore this value has to be how much here? 5 and whole square. But this however I can't here multiply, understand? Therefore immediately what you have to do into 25. Again the same step. Now what about here? 5 into, this is 4x plus 3y plus 12, and here also it is basing on perpendicular distance. Under root of 4 square plus 3 square we know it is 5, then immediately multiply by another 5. Okay, so now we completed, and whatever here this has to be there and this has to be there, therefore extra terms I am removing. 25 here and here is 25, so let us cancel. Now the equation we got, what is the equation? 3x minus 4y by 5 whole square is equal to, here it is 1 into 4x plus 3y plus 12 divided by 5. Okay, so here mod like that we are not having, directly we got in this way. Now this is what actually perpendicular distance from any point x comma y onto axis. Okay, perpendicular distance, this is from any point x comma y onto which one here? Axis whole square. Axis whole square equal to latus rectum into perpendicular distance from x comma y onto which one? Actually it is tangent at vertex. Okay students, so till here we got completely all values. Now we can decide what is equation of axis 3x minus 4y equal to 0, and what is tangent at vertex equation 4x plus 3y plus 12 is 0. Every time here take care of the thing, axis always must be perpendicular to what? Tangent at vertex. So 3x minus 4y equal to 0, this is our axis equation. And next one, tangent at vertex. Okay, tangent at vertex. What is tangent at vertex? You got 4x plus 3y plus 12 is 0. This is our tangent at vertex. Then what about here? The point of intersection is nothing but, if you solve these two equations, you can obtain clearly vertex equation. And next one, what is length of latus rectum here? The length of latus rectum, if you compare, length of latus rectum is how much in this problem? It is 1. Okay, so length of latus rectum, we got the value as here 1 unit. And next one here, if at all you want again focus, directrix, everything, just make use of the same concept. That means 4a is how much here? It is 1. So a equal to how much here? 1 by 4. Okay, then focus value. What about focus? We have said here it is nothing but x equal to here a and y is 0. That means the point of intersection of what you have to take here? Capital X. This is of the form capital X. Okay, as it is you take, that is 4x plus 3y plus 12 divided by 5 equal to a, that is 1 by 4, comma, what is the next value? Y is 0. That implies 3x minus 4y equal to 0. Okay, so 3x minus 4y equal to 0. So if you solve these two students, then you can obtain clearly here focus value. Okay, so solve just those two equations, whatever the answer you got, that is nothing but focus. That means focus is nothing but what here? Point of intersection of x equal to a and y equal to 0. That is our focus. Okay. Now students, let us take this equation. Earlier we have taken one equation and same model. Suppose if they ask, that is what is equation of axis and what about different values, vertex, etc. Let us observe here again the values. Now observe here, this is our complete homogeneous part, and this homogeneous part, if I write, it is x plus y whole square. Okay, then the other part let us send to this side, that is 6x plus 2y minus 3. Okay, now you got in this way. Here observe again, if at all you have any doubt, you can just check here, delta value not equal to 0 and h square equal to ab. So once you got in this way, then what about our conclusion? This side it is always axis square and this side it is of course tangent at vertex. Once you have to multiply, divide by the kind of perpendicular distance extra values. Okay, but now this is a kind of different problem. I hope you can understand now itself. What is the nature here? Axis and tangent at vertex, always they must be mutually perpendicular, right? If this is axis of parabola and this one is tangent at vertex, then these two lines they must cut at right angle. Okay, but here how is the slope of axis here? It is minus 1. Okay, this slope you got minus 1, whereas what about the slope here you got? It is equal to minus 3, right? That means here product of slopes we are not able to get minus 1. That doesn't mean this equation is not representing parabola. No, it is representing parabola. At the same time we got like this. So again we can't say problem given is wrong. Okay, that also we can't say ruled out. Then what modification we have to do so that axis, tangent at vertex both must be here mutually perpendicular. A little bit adjustment we have to do to solve this problem. That is here just I am adding a constant value lambda. Okay, whole square. A constant I added. Then it is not our wish, however you want to add or whatever, then immediately we have to balance the above equation. How we can balance the above equation? So what are the extra terms? One is lambda square clearly. So this is our lambda square. not only lambda square, if you take the whole square, x square is there, y square is there, 2xy is there, therefore extra term is nothing but 2x lambda plus 2y lambda. Okay, so this is our extra term. Now let us take students here x value common, then it is 6 plus 2 lambda, and now I am taking y common, then it is 2 plus 2 lambda, then the leftover is constant, that is plus lambda square minus 3. Okay, now this side you got here x plus y plus lambda whole square. So this is what actually axis whole square, and this side it has to be tangent at vertex. And what is our concept? Tangent at vertex must be always perpendicular to what here? Axis. So this is perpendicular to axis implies product of slopes is minus 1. So what is this slope here? It is minus 1. And what about this slope here? If you take the slope is m2 is minus of 6 plus 2 lambda divided by 2 plus 2 lambda. Okay, then the product has to be how much? Minus 1. Implies this is minus 1, therefore this slope has to be how much? Plus 1. Then you can take m1, m2 is how much here? Minus 1. That implies it is nothing but how much? Minus 6 minus 2 lambda equal to 2 plus 2 lambda. Okay, then if I write the value this side, it is minus 8 is 4 lambda. Therefore, lambda equal to how much, students? It is minus 2. Now, once I substitute lambda is minus 2 here, then exactly you can get here one side axis, then the other side is nothing but tangent at vertex. So, what is the final equation? Substitute the lambda value. If you take this as equation 1, let us substitute lambda value in equation 1. Then what is the value here, students? Left side you observe, it is x plus y, and this is minus 2 whole square, okay, is equal to, now what about here? This is 6 minus 4, okay, 6 minus 4, so 2x, and after that this is 2 minus 4. 2 minus 4 means minus 2y, and next value here 4 minus 3, that is plus 1. Okay, so in this way you got, now you clearly observe what is this slope here? Minus 1, and this slope is here exactly plus 1. And now again, however we have done the previous problem just by using modifications, that is x plus y minus 2 divided by root 2 whole square, and into how much we have to write? Equal to 2, and this side it is 2x minus 2y plus 1 divided by, what is the denominator here? Root of 4 plus 4 implies 2 root 2. Therefore, into I have to write how much here? 2 root 2. Okay, so now 2 and 2 get cancelled. You got exactly complete standard form. Okay, so latus rectum is root 2, and this is our axis, and this is our which one here? Tangent at vertex. As usual, we solve the problem and we can obtain different coordinates. Okay.